In this video, we're going to add multiplayer support to the drum game. Now, leading up to this point, we put a few things in place here and there hinting at multiplayer support, such as the ability to save multiplayer state between the menu screens and the game screen itself. Well, here at this point, we are now ready to put in actual multiplayer into the game itself. This is going to consist of a few things, namely, most of our work is going to be done inside of the game screen. Inside of the game, we're going to need to have two instances of the song, so that as we have player 1 and player 2, of course the different players could hit different notes and end up with a different score. So we'll actually need a song instance per player, so that each player has his own, you could say, piano roll of notes going by.
Right.
So, to get all of this put together, let's actually begin in the base song class. We're going to make the song itself aware of which player it belongs to. So we'll add some state information into the song itself. So that means up here at the very top of the song class, we'll drop in, and right after we have our field establishing our lead-in beats, let's add an additional field. We'll add a public integer called player index, and we'll set that to 0. This is important because the renderer has no concept of players. The rendering system just takes in a current song. So it's going to need to gain from that song which player the song belongs to, so it can know where on screen to draw the song. But with that, that's the only thing we'll be adding into the song class. We'll simply be using that field from outside of the song class. So at this point, we need to jump over to the game screen. So bringing up the game screen file, it's here inside of game screen that we need to shift away from using a single song instance and give ourselves the ability to manage multiple songs at the same time. So beginning with the field, the first thing we'll do is change the song field to be a song array, and we'll change the field name to songs.
Okay.
Now that does mean that will currently break the song reference and all of the code.
Yeah, sure. Anything that's referencing songs is going to be broken now.
But since we need to manage this in terms of multiple songs, we'll need to address each of these areas anyway. We'll begin at the input method. Now when input is pressed, of course we can look into input data and figure out which player that input is coming from. So we're going to need to use this code here to act as kind of a routing mechanism. So we'll read the player from input data and then address the appropriate song using that player. So what that means is here inside of our input, once we have found that the input is a note, we need to route the note presses to specific songs. So first what we'll do is we'll make sure that the incoming player is within bounds given the number of song instances we have. So we'll check and make sure that input data dot player is less than songs dot length, just in case for some reason, maybe because of a binding error in the config XML file, somehow we get in player 27, which obviously doesn't exist if you have two songs. So we'll make sure that we do have a sane value inside of the player field. Now, if we do have a player that is within bounds of our songs, that means we need to address a specific song in order to invoke press note. So we'll look into the songs array, and we'll address an element by player. So we'll drop in input data.player, since if we do have an appropriately bound player for a two-player game, that's going to be player 0 or player 1. And if we have two songs in action, then that will be song 0 or song 1. So that way we'll address the appropriate song and invoke the press note method. Alright, moving on from here, we can now address the reset method. And inside of reset, we need to initialize the songs array and then drop the necessary number of songs into it. So it's here where we will say that songs will be equal to a new song array and give the appropriate number of elements. And we'll do that by looking back at global state. Matter of fact, very briefly, I'm going to jump down here to our game and load up the global state class just so we can review the state information available for multiplayer. We have two fields, one field indicating the maximum number of players currently supported by the game, And the second is the number of players selected, meaning in the case of single player, this will be 1. In the case of multiplayer, this will be 2. So we can look at this field from the game screen. We can drop in global state dot num players, and so that's the current number of players. We'll use that number to initialize the songs list. What this means is in single player, we'll have a songs array with 1 element, and in multiplayer, we'll have a songs array with 2 elements. Alright, now we need to put together the songs themselves. We'll reuse most of this code that we're currently using to initialize a single song and apply that inside of a loop to initialize all of the songs currently in use. We will drop the set tempo outside of this loop, since set tempo only needs to be called once.
Right, because you're not going to have 2 separate tempos.
Exactly. And that is an interesting point. These 2 songs, even though they are independent instances, they need to be handled and updated the same. They have to be kept in sync with one another. Alright, let's put together a quick for loop. And we're going to loop through all of the players we currently have, which we've stored in songs. We can look back at the songs array, look at its length, since we've already set that to be the appropriate number based on the number of players. Now I'm going to drop off the closing brace and re-add it at the end of our song initialization code. So all the song initialization will take place inside of the loop. Now as we're looping through, we'll be looping through each song. So in order to address a specific song, we have to look at songs sub I. So we can simply replace that. We can even take S sub I and drop that onto each of our song references here. Since we're going to be doing the same type of thing with each of our calls, we just need to address a specific song. So we do the exact same setup for each song. Songs element 0, then songs element 1. And let's see. One thing we do need to add in addition to the calls replacing here is we also need to make sure that the song is aware of what player it belongs to. So that means we need to drop in here and say songs sub I dot player index is equal to I, to make sure that player 2 gets assigned a player index, 0-based index of 1, and that way the rendering system will be able to tell which player the song belongs to. So now that we've got all of our songs getting set up inside of the loop, we can now move on to update and draw. Because once again, we still need to handle the fact that we have multiple songs. Now before we jump out of the reset call, we still have our set tempo call, which is looking at an individual song. We'll address songs sub 0 before we pass along the BPM and ticks per beat. Because again, set tempo doesn't care about multiple instances. It just wants to know what the current tempo and division is. So we'll pass that along from songs 0. Because in either case, we will have an element 0. Single player will have only 1, and a multiplayer will have 2, but of course element 0 will still be accessible. Alright, now I can move down to update. Inside of update, we need to loop through all of the songs and make sure that each song instance gets updated. So once again, we'll put together a for loop that will loop over songs.length, and that loop is going to cause the current song's tick method to be called. We'll take out the braces and just put in the single statement, and now we can address songs sub I because we're inside of the loop. So make sure that both songs get updated at the same time for update. Alright, inside of draw, we also need to make 2 separate calls to the renderer. So we're going to use our renderer's draw method twice in the case of multiplayer, but we'll pass in the correct song for each call. So once again, we'll make a for loop, and just to save time, up here in update, I could grab the existing for loop call.
Right, because it's the same loop.
We need to do the exact same thing, loop over all of our songs. Then when we make the call to draw, we'll pass in songs sub I to pass in the current song. Alright, now that should have our game screen properly upgraded to support multiplayer. Now we can jump over to our renderer horizontal class and make sure that the second player's song is placed on the bottom half of the screen. So to do that, we'll bring up the renderer horizontal class, and we will scroll down to find the getStaffY method. Here we're currently running a calculation to get the center of the top half of the screen. And what we need to do is we'll do a check and see if we're looking at the second player, player index sub 1, and if that's the case, offset by half a screen's distance to move from the location we would otherwise get with this calculation, move that location to the bottom of the screen. So we'll put in an if statement, and we'll say if song.playerIndex is equal to 1, again, player index being 0 based means a setting of 1 means player 2. And if that's the case, then we'll do whatever we need to do. We'll put in an else clause
to draw only one staff.
Right, so we'll leave the current code alone for a single-player game, or, excuse me, for a song belonging to player 1.
Right, right.
We'll move to the top of the screen. Now, if we're looking at player 2, I'll begin by copying the current return, since that has our positioning calculation, and paste that into the body of our if statement. So this properly finds the center of the top half of the screen. So we could build on this and simply say if we found that position, we could offset by half of the screen's height, and that will move us to the bottom half of the screen. So we can drop in global state.fixed drawing height divided by 2. So use the same calculation, just moving to the bottom half of the screen. And that is the only change we need to make inside of the renderer. So from here, we can move on to, let's see, a few different things. At this point, we should be getting close to being able to test. Before we do, I do want to change the bindings on the gamepad so that we bind the gamepad to player 2.
Okay.
In order to do that, we'll jump into our content project, load up our config XML, jump down to all of our input bindings, and we'll take all of the bindings for gamepad, and we'll assign the gamepad to be player index 1, giving ourselves the second player. So now when we jump into the game, we should be able to test and have the second player able to play notes. So at this point, let's build and run the game, and let's see. We're still not out of the woods yet as far as errors are concerned. We need to address this error here inside of Draw. We were using the song's tempo setting in order to draw BPM on the screen.
Right.
Song no longer exists.
No,
so
it has to be song sub-I.
We can drop in, well, in this case,
Sub-zero.
we'll drop in sub-0.
That's true, because it really doesn't matter.
Exactly. We've got the element 0 is always going to exist.
Yeah, exactly. There will be occasions where the other one won't.
So let's build. Building has succeeded. So let's jump in and run the game. Let's grab multiplayer, and we'll grab the rock song. Now here with the player 1, now notice the way that this sounds currently. Just hitting the hi-hat sounds really weird because we're getting sounds played every time a player hits a button, whether that player be player 1 or player 2.
I'm terrible at this with the controller, by the way.
And that's funny too because we're using a controller instead of a drum set to test here. And I wasn't even bothering to press anything except the hi-hat. But already we can hear that there's a problem. The notes coming through are all jumbled together because player 1 could hit a note at a slightly different time than player 2.
So how are we going to solve that problem where you end up hearing double drums most of the time?
Well, let's change the audio playback rules in the case of multiplayer. For single player, we'll leave instant playback alone, meaning the player is actually driving the sound by hitting the given drum. In multiplayer, we can't do that because it would end up sounding chaotic. So what we'll do is we'll put the game audio-wise into autoplay mode. That means in multiplayer, the song will be playing in the background, and the players are just responsible for hitting the notes on the specific track.
So multiplayer becomes kind of a scoring game as opposed to a music playing game.
Right, because in multiplayer, we're not going to have the players influence the music. We'll simply have them influence the notes that get hit.
Gotcha.
So in order to do this, we'll change our note hit and note play handlers inside of the screen game class. So if we jump up here, we have our note hit and note play. In note hit, we need to change this so that our play call only gets called if we're in single player. We'll do that by checking global state dot num players. If that is equal to 1, then we are in single player mode, and we can freely play track hits every time a note is hit. Now if we're in multiplayer, we want to drop into our note play method, and we'll play a sound as long as we are in multiplayer, then we'll just handle autoplay. So we can put together an if statement that says if global state.num players is greater than 1, then we're in 2-player mode, and we can freely play the song hit.
Now, if you didn't like this concept where the game is really kind of just playing itself and you're just trying to score, an alternative that you have as opposed to doing what we're doing here would be to make sure that you build custom songs specifically for multiplayer to make sure that the 2 players are not playing at the same time. So you play one player 1 could play, and then make sure you switch over to player 2. So, because the problem is, if they're playing at the same time, then you could get that funny offset. If you build special songs where that sort of thing happens, of course, you'd have to make sure that they're not actually playing the same song at the same time. You'd have multiplayer version 1 for player 1, multiplayer version 2 for player 2.
Right, and then what you'd need to do is when you're loading in your songs in multiplayer, you'd have to have player 1's variant loaded into element 0 and player 2's variant loaded into element 1.
Right. It would take some change to the architecture, but I'm just throwing it out there for people who want to explore further as an option you could do if you didn't want to have this auto playback style of multiplayer.
Right. What's interesting is code-wise, that would only require very minor changes. Mm-hmm. The bulk of the work would be in setting up songs that jump back and forth pattern by pattern. Or
exactly. It'd all be about song design at that point.
But in our case, since we, at this point in time, lack advanced song designers, we're simply going to drop into autoplay mode. Now, with this if statement here in note play, if we're in multiplayer, playback notes, that's all well and good, except for the fact that we have to keep in mind that 2 different song instances are linked up to this event handler. If we look back here in reset, we've got songs inside of the loop. Both songs end up pointing at note play. We don't want to play the note twice every time it goes by in the song. So here inside of our handler, we'll make sure that we only play the notes for song 0, meaning we will look at song's player index. And if that's equal to 0, then we'll go ahead and play. Since again, the information, or rather it should be songs sub-0, the information in each song at this point should be identical. So we're only going to play the song if we're looking at player index of 0. So we've got, if we're in multiplayer, and the song player index, I see what's going on. I was looking at the wrong reference. I forgot to put the AND operator in place.
Watch sing.
So, there we go, end spelling. Okay. But basically, just to rephrase, the current song instance is being passed in via the handler. Mm-hmm. Then we can ask that song instance what player it belongs to, and only play notes for the pattern or the song belonging to player 0.
Gotcha.
Alright, in that case, let's go ahead and jump in and test. Now multiplayer should play the song in its entirety, regardless of what notes we hit. So jumping into multiplayer, again grabbing the rock song. There we have the correct sound of the song. And now we get different note presses. So player 1 and player 2 can end up with an entirely different set of note presses. Now, at this point, we have multiplayer functioning. As a matter of fact, let's test, make sure single player still works. We don't want to inadvertently break something. So let's jump into the same song, and here we have a single track, and it's obeying player 0, which is the keyboard, and try hitting buttons on the controller.
Nothing!
And so we're not bringing in button presses from the controller. So at this point we support both single player and multiplayer inside of our game screen. So we've got everything set up and working very nice. And in the next video we'll address scoring. So that will wrap everything up for this video.